Bismillahirrahmanirrahim. My name is Fahimullah Babar. I'm your physics teacher. We are in chapter number 4. We have already covered some of the articles, and the article today is work done in the gravitational field, and it is FSC part first. A gravitational field is related to the Earth's surroundings. We can define some of the basic terminologies before entering the regular article. That is about the gravitational field. It is that area around the Earth in which the effects of the gravitational force can be felt or detected, or we can feel. It always remains attractive or positive, and there is no concept of repulsion in the gravitational field, but every time attractive. It means the gravitational field is always positive and always attractive. Next, we use the term weight of the body, and the general expression we use for the weight is W is equal to mg, or G is equal to W by m, as we can shift the m to this side. So G is equal to W by m. In System International, the unit for W is Newton, which is a force, because weight is a force, and m kg. So in this way, this is Newton per kg. And G also equal to meter per second square. If we take Newton, it is a force, and if you use the previous formula, F is equal to ma, and you cancel the mass with mass, so we will be having meter per second square for the acceleration, which is also termed as the strength of the gravitational field in the form of ratio of weight of the body to its mass, different W by m. In a System International, Newton per kg of the body, it is pronounced like that. Next, when we will do some work in the gravitational field, it will be against the gravity or will be towards the gravity. So it means we can go up against the gravity and we can go down towards the gravity. So both the cases are possible. Then the further article can be divided in two parts. Number first, work done in the gravitational field is independent of the path followed. It doesn't depend on the path through which path either you are following a lengthy path or a shorter path. So in the gravitational field, the amount of work done in a closed path will remain the same. And the total work done in the gravitational field in a closed path equal to 0. If there is a closed path and it is in the gravitational field, so we will say that the total work done in the gravitational field in the closed path is 0. So let's take the first part. The work done is independent of the path followed in the gravitational field. What we do, let there be a closed path in the form of A, B, and C, and this is in the gravitational field, and we are considering an object of certain mass to be displaced from point A coming to point B, covering a displacement d1, and the angle theta is the angle between the force applied. So here the force acting upon the body, that is equal to its weight, almost equal to its weight. Similarly, when we come from point B to C, here we are going to apply a force which is almost equal to the weight of the body, and the displacement covered is d2, and here you should remember the angle between these two quantities is 90. So similarly, if A to B, B to C, then we C to A back. Remember, if we are considering the weight over here, which is equal to the force we are considering, and this is the angle theta, so this total is 180, and this theta is minus, this is subtracted. So how much angle is left to this side when you are moving from C to A? This is 180 minus theta. So now we can say that AB is equal to D1, BC is equal to D2, and CA is equal to D, and the angle we have given already. So anyhow, work done from point A to C directly, that is the dot product of the force and the displacement covered, which is equal to FD cos theta, and W is equal to F, we have told there, so WD cos theta. So work done from A to C is WD cos of theta. But remember, if we focus on the figure and we take the cos of theta, so cos of theta, the angle is over here, and this is equal to base divided by hypotenuse, which is d1 divided by d. So we can shifting cross multiplication. So d, when d is shifted there, so d1 is equal to d cos theta. So it means in equation number 1, the d cos of theta will be replaced by d1, and very simply the work done from part A to C will be is equal to w d1. This is called one of the equations. 3. So similarly, work done from A to C can also be taken work done from A to B plus work done from B to C. It is the same thing that work done from A to C. So that was work done from A to C directly. Now this will be work done from A to C in parts from A to B, then B to C. So we have added. So work done from A to B, if you see, work done in the dot product of the force and the displacement covered, and WD1 cos of theta 1, and here WD2 cos of theta 2. So the angle over here is 90, and the cos of 90 is 0, and cos of 0 is 1. So simply it will give us WD1. You see, WD1. So now if we compare equation number 3 and equation number 4, so we will find that equation number 3 is equal to equation number 4, and the WD1 is the same in both the cases. So work done from A to C in a direct path is equal to work done from A to C through an indirect path, or we can conclude that the work done in the gravitational field is independent of the path followed. It doesn't depend on the path, either you are going directly or you are coming over here or you are coming over there, but the same amount of work will be done. Next is the total work done in the gravitational field in the closed path is 0. Again, if the work total, the work done from A to B plus work done from B to C plus work done from C to A. So the same thing has been repeated in another way. Now A to B, WD1 cos of theta 1, it is the same. WB to C, WD2 cos of theta 2, okay. And work done from C to A is WD cos of theta. So you see from C to A. So the total closed path or loop has been covered. So here theta 1 is 0, bilkul. Cos of theta 2 is 90 degrees, and cos of theta, from the figure you can see it is 180 minus theta. This 180 minus theta, this can be simplified by using the formula cos of alpha minus beta, cos alpha cos beta plus sin alpha sin beta. So this can be considered alpha, this can be considered beta, and if you are having minus, this will become plus. If there is a plus, this will become minus. This is a mathematics formula from trigonometry, you will know better. WD1, so therefore cos 90 is 0, and over here sin 180 is 0, but cos 180 is minus 1. So this will be giving minus cos theta. So WD1, and this minus will come out, so plus minus is minus, WD cos theta. And from the previous equation we have written, the d cos of theta is equal to d1. So therefore this expression will be replaced by d1. So WD1 minus WD1. So definitely straight away they will be cancelled. So work done total is 0. So it means that it is quite clear that the total amount of work done in a closed path in the gravitational field is equal to 0. So this is another, if we change the points A, B, C note, but like this A, B, C, so the same philosophy will happen. Either you are calling it D1 or D2, this is D1, this is D2, this is D. So it makes no difference, this thing will remain the same. So now, so such a field, the conclusion is, we can conclude now that the work done in the gravitational field doesn't depend on the path followed, and the total work done in the gravitational field is equal to 0. So such a field in which this thing happens, this is called a conservative field. Right? These two conditions are fulfilled, conservative. Electric field is a conservative field, magnetic field is a conservative field. And this is the conclusion, and this is the article we have considered, and this was the chapter number 4, the article work done in the gravitational field. And that's all. And inshallah next time we will consider the absolute potential energy. Good luck.